if I have an inverse, then it's got to be square n by n. So what's the shape of the sigma guy? Also square n by n. So the invertible case would be, and I'm going to erase this in a minute, the invertible case would be when sigma is just that. That would be the invertible case. So let's see. Can you finish this formula? What would be the SVD of A inverse? So I'm given the SVD of A. I'm given the U and the sigma is cool and the V transpose. What's the inverse of that? Well, yeah, I'm just really asking you what's the inverse of that product of three matrices. What comes first here? V. The inverse of V transpose is V. That's because V is a orthogonal matrix. The inverse of sigma, I just went over it. It's just the sigma inverse. It's obvious what that means. And the inverse of U would go here, and that is U transpose. Great. Okay, so this is if invertible. If invertible, we know what the SVD of A inverse is. It just takes the V's back to the U's, takes the, or the U's back to the V's, whichever. Okay, okay. Now we've got to do it if we're going to allow, if we're going to get beyond this limit situation, allow the matrix sigma to be rectangular, then let me just show you how the idea here. So now I'm going to say, now sigma, in general, it's rectangular. It's got